Okay, let's see what we got today. It looks like a medium problem that I haven't done before. I was thinking back to yesterday's problem, and I think I could have made it faster, even though it probably didn't show up in the graph if I made it like a static array of like every 100 answers, or and just have a pre-computed answer for that. But whatever. Okay, so today, 4 divisors. Given an array, integer array, return the sum of the divisors of the integers in that array that have exactly 4 divisors. If no such integer in the array exists, return 0. The sum of the divisors in the exactly 4 divisors. So 1 in itself is 2 divisors, and then 2 other divisors. Okay. 21, 4, 7. 21 has 4 divisors. 4 has 3 divisors. 7 has 2 divisors. So it's just 21. So why is it 32? Return the sum of the divisors. Oh, okay. So sum of these 4. 21, 21. So that's okay. Interesting. I'm not gonna lie, this is finding like divisors and whatever is something I don't find particularly pleasant because it's mostly functions that I never memorized, to be honest. Finding grit GCD. I guess there's probably GCD, GCF function in Python. Yeah. Sum of divisors. Okay, so the nums. Let's see what the. So the nums are between 1 and 10 to the 4th, or 10 to the 5th. The length is 10 to the 4th. Interesting. Okay. I wonder if it makes a difference if I sort it. Maybe. If I sort it, probably wouldn't hurt. I mean, it's gonna be, if I don't sort it, then it's gonna be O of n in theory if I can somehow do constant time factorization. Constant time factorization. Oof. So what's the smallest number it can be, really? So I mean, I can pre-compute maybe everything that has four divisors within 10 to the 5th, maybe. I can pre-compute that. Probably don't want to, right? It's probably 10 to the 5th is 100,000. Yeah, it's too big. So on the fly, the fastest way to find divisors of an integer. 1 and the number, and then there has to be 2 more. Can't be 2 more. I guess it could be like 2 primes, right? It could be like 5 times 5 times 7 times 7. So like 25 times 49 times 1 times whatever 25 times 20 times 49 is. 25 times 49. Huge number. Return the sum of divisors of integers in the array that have exactly 4 divisors. Could do a default dictionary, maybe. I think, even though I don't know that it's necessary, I think this makes it easier for me to sort. And then maybe for every value in nums. I need to determine if val has 4 divisors, and if so, what they are. So let's say divisors is an array. I'll do something like answer plus equals the sum of the divisors. And here I say if the length of the divisors is actually equal to 4, then do that. Okay, that's kind of the skeleton of the code. Now the question is, how do I find divisors or stop myself from going too much? Obviously one and it's 1 and the number itself would be a pair of divisors. Obviously it wouldn't work for 1, but 1 is like whatever. 1, 3, 7. Think about this. If you have 4 divisors, does it necessarily need to be the 2 middle divisors are prime? Does that have to be the case? Probably not, right? It could be like 5, 25, 125, 1, 5, 25, 125. 5 times 5 times 5, 25 times 5. Yeah. 1, 5, 25, 125, that would be, the 2 middle ones aren't prime. 25 is kind of close to prime, but not prime. But it might be the case that the 2 middle ones have to multiply to the top one. Is there any case where that's not true? Like here 21 has 3 and 7. 3 times 7 is 21. I think that has to be true, right? The 2 middle one has to multiply to the biggest one. When would that not be true? Yeah, I think that's true. So it has to be, so the number has to be a composite of 2 primes, basically. Composite of 2 primes. Not necessarily 2 primes, I guess. It's a composite of the 2 middle numbers. The 2 middle numbers are likely to be prime, but not necessarily. Like 5, 25, 1, 2, 4, 8, 1, 3, 9, 27. So like 8 and 27, 125 would all have 4 divisors. So not necessarily 2 primes, but 2 factors for sure. So the 2 factors have to multiply to the number itself. 2 factors are non-1, and there cannot be any other factors. The lower number has to be prime, right? So the bottom number has to be prime. I wonder if I can quickly identify that. If I iterate over each number, iterate over from smallest to largest. I guess from smallest to the square root of the number. What happens if the number's even? So if the number's even, it's like 1, 2, 4, 8. This obviously works. I think that might be the only even that works, right? Is there any other evens that have 4 divisors? Because if you do something larger, like 1, 4, 16, 64, that obviously has a 2 divisor. 1, you do any number besides 2 as your second divisor, second smallest divisor. Then the next number has to be a prime. It has to be like 3. Okay, it has to be a prime there. So it's 3. If it's even, then the only other number it can possibly be is 4. It's like 1, 2, 4, 8, or 1, 2, some odd prime. Like 3, 5, 7. So it's even. If the number is even, I divide it by 2. That remaining value has to be an odd prime. Odd prime number. And then if the number's odd, then there's no limit there. If the number's even, divide by 2, it has to be 4 or an odd prime in order for it to have 4 divisors. If I have how do you even go about factoring numbers quickly? Oh my god, so bad at these. 21, 1, 2, so 21. Factoring it, you can always stop at the square root of the number, I guess. So you can stop at 4-ish, 4 or 5. Stop at 4, I guess, because 5 is just too big, right? So 4. So just check 1, 2, 3, 4. 3 evenly divides it. 3 evenly divides it, gets 7. And that has to be a prime as well. Well, no, because nothing else divides it, so yeah, 7 has to be prime. Given array nums, return the sum. I guess the divisors actually is just going to be 1, the number itself, and then those 2 other numbers, right? Just like A and B. So I think it should be. How do I handle that? I think maybe div A and div B, maybe? Div A, div B. 1 plus the value plus div A plus div B. And then I'll probably just make this somehow continue if some condition. Div A, div B. So if the number itself is 2, or It's not going to work if the number is divisible by, let's say the number is 2 times 15. So that gives me 30. I'd have to somehow check that 15 is the prime number. Like maybe I could keep track of my primes somehow. I could keep track of my primes somehow in the list, or in a set. Would that work? 4 has 3 divisors, 1, 2, 4. Okay, time to use some Google AI. Fastest way to get a set of primes up to 100,000. Fastest way to get primes up to 100,000 is using the optimized sieve of ERA, especially segmented or bit-packed version, which efficiently eliminates multiples by marking them off in a Boolean array, saving memory and dramatically speeding up the process compared to trial division, making it the standard for finding all primes in a range. Top method: segmented optimized sieve. I think it's sieve, right?
Sieve.
Instead of making multiples of each prime of the giant list, use sieve in smaller segments and only sieve within those segments, using primes found so far up to swerve and reduces memory and improves cache performance. Bit packing: store the sieve as a bit array using 1 bit per number instead of 1 byte per int, effectively using 8 times less memory and boosting speed by checking multiple numbers with bitwise operations. Wheel factorization: optimize further by skipping multiples of small primes like 2, 3, 5 within the sieve, further reducing numbers you need to check. Oh my god. I've not done this before. Or I guess this is something that I just don't, I lose memory for. I've done it. Might still do it, but I definitely will forget it. Avoids division. Says avoid slow division modular operations for most numbers relying on addition and bitwise logic. Value reference segmented sieves keep data in cache, making them very fast in practice. Create a bit array representing numbers up to 100,000. Mark 0 and 1 as not prime. Iterate from 2 if a number p is marked as prime. Mark all its multiples as not prime starting at p squared. Use optimization like skipping even numbers or using bit shifts for efficiency. Collect all numbers that remain left as prime. I don't know what it's talking about here. Why this fastest runner that has been simple or advanced, while the sieve of Atkin has a better theoretical time complexity. It's significantly more complex to implement and typically only faster for extremely large ranges, about 10 to 9 due to higher constant overhead. Memory efficiency for n equals 100,000. A standard monolithic sieve fits easily into modern CPUs, requiring only about 100 kilobytes. making specialized segmented sieves unnecessary for specific limit. Avoid trial division. You can implement the sieve efficiently for a limit of 100,000. Use a Boolean list to keep track of primality and iterate only up to the square root of your target. Okay, initialize a list with true representing all numbers of prime. Prime of 0 equals prime of 1 equals false. 0 and 1 are not prime. Sure. Only iterate up to the square root of the limit. For p in range 2 to math of square root of the limit plus 1. If the mass array at p is true, then for all I in the range of p times p to limit plus 1. So from p squared to the limit going up by p. So if p is like 5, starting at 25, going up by 5s, setting it to be false, setting the prime mass to be false. Extract the numbers that remain. For every number, for every num is prime. Actually, do I understand this list comprehension expression? Oh my gosh. Num, for every num, what is going on here? The num value for num is prime if this prime is true. Num for num comma is prime. So I think this is a for each loop, right? For each number and is prime in the enumerate. So this num is the index, which matches the value of the number that you're trying to qualify as prime or not. Is prime. So this is the index value. So the value is this Boolean true or false. I've never done a list comprehension like this actually. I wonder if there's another syntax for this equivalent. Anyways. Get primes up to 100,000. Use code with caution. I guess I can use it to limit. Okay. I'll copy this part. I guess I should probably copy this part too. Okay. I guess I should paste it here. Generously taken from Google AI. Okay, so I guess I can call primes. I'll use the nums dots, the last number, the largest number. I wonder how fast it is. Guess I don't need this anymore. Just use the primes array. Okay, so for every value nums, I guess I wonder how many ones or twos there might be. So I think the logic should be pretty straightforward here. Maybe I don't even need the condition. So it needs to be, I guess the logic does need to have some things to it. Ugh. Oh gosh. Yeah. Ugh. Find the sum of divisors of integers in that array that have exactly 4 divisors. So the odd stuff is going to be the key thing. So like the easy stuff would be that if the value is less than, if the value is an even number, then let's say I get the other factor is equal to value divided by 2, and this other factor needs to be a prime or needs to be 4, right? So if prime, if the other, so that if the other is prime or the other equals 4, then it works. So answer plus equals 1 plus value plus 2 plus other. I think what's the other one, right? 2, 4, 8, 1, 2. Yeah, I think that's the only thing, right? Okay, so else, so if it's an odd number, the odd number is going to be needs to have basically needs to have a prime divisor, some other prime some other odd factor. Needs to have exactly, I guess I can do GCF, greatest common, find smallest Okay, find factors of a number. How did I do that? Using square root optimization more efficient. Yeah. It seems still kind of slow. Because I probably don't want to do this so many times. So if I did, so number 7. So I guess maybe if I think, okay, so I think here, else if the value is a prime, then I skip it, right? Prime of this value, continue. So here, this is a non-prime odd number. So it's odd would be false here, false in the first condition. And then this is going to be stopping it, okay. So how do I check the divisors of this number, which is also increasing with the sorted array? Maybe I shouldn't sort the array, to be honest. Could just find the maximum so that the maximum is used as the parameter, the limit parameter for this call, and then I just do it normally without sorting. Because if I did sort it, then this is kind of inefficient given that some values are repeated, and I don't want to do the whole calculation for those repeated values. I guess I could make this numbers into a set and then sort the set. Oh boy, oh boy, oh boy. The answer is the sum of the divisors of 21. Snappity dappity boo. Guess I should. I could iterate over the primes. Could iterate over the primes. Prime. Iterate over the numbers from 1 to, or from 3 to the square root of the number, going up by 2, 3 up to the square root of the number, seeing if that number is a prime and that number divides into the other number such that the remaining factor is either the square of the number or another prime. Okay, I think that might work actually. So for, let's say f for factor, this factor, in range from 3, there should be a limit here. Let's say the limit is nums at -1, the last number in the sorted array. Actually, this should be the limit, should be the square root of the number, right? Integer of the square root. Was it sqrt? Math sqrt. Square root of the number itself, which is value here, going up by 2. The factors in this range, then 3, 5, 7. Actually, it shouldn't be an if, this should be 4, right? For factor in range, if the factor is a primes, if the factor is a prime, and if the factor is a prime, no, oops, no, this should be, yeah, I guess the first thing is if this factor is a prime. And I guess also, and the factor divides into it, right? Val divided by factor equals 0. The remainder of val divided by factor equals 0. Then I can probably do others equal to factor val divided by factor. If the other number, the other number is not itself, right? It can't be 5, 5, 25. If the other number is a factor, so the other number could be the square of the number, or it could be another prime. If the factor, this is a prime factor, so if the other number is equal to the square factor, or it's a bigger prime factor, or it's a prime number and it's a bigger number. I guess it just could be not equal to factor. Seems so bad. The logic here should be simplified somehow. I'll figure it out if this is correct. Then this is all good. Answer plus equals 1 plus factor plus other plus value. Else I think you break. Because you identified a factor, like let's say it's 3, and it's multiplied by 15, so it's like 3 times 3 times 15, or 3 times 15 is 45, so 45 has 3, 5. No, 45 is, yeah, I guess 3, 5, 15. Yeah, I think that might work actually. Some pretty gnarly looking logic. Let's add a range. Primes of value. Every value in nums. Really? What is what is the 21? Oh. Oh, whoopsie. It gives me a list, huh? Of the actual primes. Oh. I thought it gave me an array of the thing. But it converted the array into actual numbers of primes. Maybe I need a set then. Yeah, I think I need a set. Num for every number. Yeah, I just need to convert this to a set, I think. And then I need to convert all my expressions using it. So this is other is in primes. Also if the value is in primes. If the factor is in prime. If the other is in prime. Oh boy, oh boy. Not good, huh? 41. So somehow it added the 7, like 1 plus 1 plus 1 plus 7 plus, I don't know. Let's say here val works. What is it doing here? Somehow it got 4 works. That's not good. So 4 is divisible by 2. The other thing is going to be 4 divided by 2, which is 2. 2 is in primes. I see. Yeah. Logic is very, very leaky. My intention is other is going to be a non. Other is 4 or other is a odd number. Maybe I should just get rid of 2's in prime, to be honest. 2 being in this prime thing really does screw things up. So maybe if I just remove it. Primes dot remove 2. Yeah, maybe that works. Okay, I need some more test cases here. Let's do 25, 125, 27 should work. 9 shouldn't work, 16 shouldn't work, 8 should work, 10 shouldn't work, 100 shouldn't work. Okay, well, it worked. Okay, let's just run it. Let's see how slow this is. I'm guessing it's pretty darn slow. Primes removed too. Because the limit's small. Right. I guess maybe I shouldn't actually sort, right? I don't think I actually use sorting. Let's say I should say limit is equal to the maximum of the nums. And then if the limit is less than or equal to 2, then just return 0. Wonder if I should just do higher limit actually. Because the lowest number it could possibly that is actually has 4 divisors is 8. So maybe less than or equal to 7. Or less than 8. Return 0. Fun with that. Do. Wrong answer, you say. Unfortunate. Hmm. Do. It's a pretty big difference, huh? It's off by 2 million. So maybe my big values are not doing this correctly. Why wouldn't I be doing it correctly? Feeling this removing 2 is a little questionable. Primes. So if the value is divisible by 2, then the other factor is going to be value divided by 2. If the other value is a prime, so it's an odd prime, or the other value is 4, and that's good. Else if the value is orient primes, skip it. Yeah, we wouldn't have 4 divisors. Otherwise factored, and 3 to the square root of the value. I wonder if it should be square root plus 1. Yeah, whoops, it should be square root plus 1 because maybe it should be the square root as possible. Because it's not inclusive of the higher value. Oh, shucks. Yeah. Guess it's the same answer as before, yeah. No, actually I did bump up my answer. Okay. Well, still not good enough here. Math dot square root of the value. I mean, it's an odd number, right? 3. Actually, maybe this should be, because the thing is actually, maybe I should be doing a set, to be honest. For factor in range. maybe it should be both a set and a list. Yeah, this is okay. Let's go back to the list, and I'll call this the prime list. And I'll call this the prime set, and it's equal to the set from the primes list. I'll call this, I guess I'll call it the P list. P set. What am I doing here? It should just be limit. Oh boy. Wonder if that screwed things up. I guess I'll call this the primes. I don't think this works. I think I screwed up so much here. Okay, actually it was the fact that I was using the sorted version as my limit. Okay, I think this is too slow. I think I should be using a set and a list here. But let's see how this goes. Okay, interesting. Yeah, I think if I'm confusing myself in terms of when I use a set and when I'm using a list. So I have a list here, returned from the method, convert it into the set called primes. I think using sets here is fine. Yeah, it's pretty fast for this part. But then using the list for this part is probably better. Because I don't want to iterate over all the odds and then have to check if the odd is actually a prime. I can just check. I can just use the list. So I think for every factor in plist, I think that's probably fine. And then I can say if the value mod this factor is equal to 0, so it's divisible by this factor, then if that's the case, then other is going to equal value divided by factor. If other is equal to the square factor, or other is not equal, other is in primes, and other does not equal the factor. I guess this should be if the factor is in plist, for every factor in plist, I guess I should actually do something like if the factor is greater than I guess if the factor is greater than, gosh, it should be something like high is equal to integer math of square root of the value plus 1. And if the factor is greater than high, break. I think that's right. Value mod factor equals 0, so it's divisible, other divided, other. If that's the case, then this works. Answer plus equals 1 plus factor plus other plus value. Else break. Actually, it's always going to break here, right? It's always going to break. So if it finds the divisible factor, then it's going to do logic to see if that works. To have 4 divisors. I think that's right. Output. Okay. Let's see if this is any faster than the other one, or if it even works. Greater than high. Greater than or equal to, greater than high. I think it should be integer math out square root. I think it doesn't need +1 here. I think it's just greater than high here. I wish this could just, yeah. Iterates over the primes. If it sees something that's divisible, checks the divisor or the dividend. Dividend either has to be the square or it has to be another prime that is not the same as this one. I wonder if I can somehow combine this logic. So other has to be the square of the factor. For other has to be another prime, but it can't be this thing. Okay. Maybe I can get rid of it by limiting the high to be slightly below the square root. Right? Like, it can't be actually the square root. So maybe it should be high if factor is greater than or equal to high. And at that point, I don't think I need this. I don't think I need this other conditional. I think that's right. God damn it. Why? Ugh. I thought I had the logic right there. Okay, so if factor is greater than or equal to high, well, yeah, square root of the number is rounded down. Ugh, whatever. Whatevers. Sometimes you live with the mess. Alright, that's it. I'm done. Okay, so what to say about this? Summary. Okay, so use Google AI to get the sieve of Erat however you spell that person's name. Algorithm to quickly get the prime factors or the prime numbers from 1 to 100,000, which is or 1 to the limit. Here, 100,000 given the parameters. From there, use logic to determine how many divisors a number has. In particular, if the number is even, in order for it to have 4 divisors, it must be 1 times 2 times odd prime times the value itself, or 1 times 2 times 4 times 8. Like the number has to be, actually I guess the smallest number is actually, yeah, I'll use 8. Any other thing wouldn't work. For an odd number to have 4 divisors, it must be 1 times odd prime times different odd prime times the value, or 1 times odd prime times square of same odd prime, square of that prime times value. No other combination works. So use the prime factors and prime set if converting list to set appropriately with that logic, and calculate sum of divisors accordingly. Okay. So yeah, it's like you have your values in your nums array after you've got your primes, and I create the p list, the prime list, and also the primes set. And then if it's even, use the first logic. And then if it's odd, after I kind of remove the prime itself, because it can't have a prime number if you have 4 divisors. I wonder if I actually need that. I think I do. Yeah. Time complexity, this is going to be O of k, where k is the largest member in the list, which in theory should be O of n, I guess. O of n. I don't know. Yeah. Okay, where k is the largest list. To construct the sieve slash prime factors prime array. There it is roughly O of n, where n is the number of values to determine the sums. The sums of the divisors. Space complexity, this can be okay. To store the array slash set of primes within the bounds. Okay.